going to do is we're going to look at how bioaccumulation and biomagnification are different. Um, and we're going to use that using food webs and food pyramids because they're kind of related. The same way that energy travels through a system of trophic levels, toxins can do the same thing, like pesticides like DDT or heavy metals like mercury. The reason why is because they're fat soluble. They're trapped in the animal. They don't escape from the animal. So concentrations can build up. So the first thing we're going to do is kind of build a food web of these aquatic organisms. So in the center is a zooplankton. It's like a little microscopic shrimp. So you have zooplankton. Then you have small fish, you have shrimp, you have tuna, and then you have a shark. So we're going to create a food web. To do that, we're going to use the arrow functions on Smartboard. So we're going to choose the arrow that has a blunt end and then an arrowhead. Now, always remember, the arrow points to the direction of energy flow. So when we make this, what's one way that I can draw an arrow on this picture? So the zooplankton to who? So the way you do it is you just click on the zooplankton and you drag it towards the shrimp and you let it go. And it creates an arrow for you. So that showed energy flow, okay? So since this, I want to make a little interactive. Does anyone want to come up and try some? Go ahead. So make a couple of arrows showing direction. Show about 3 flows of energy. So go ahead and show one. So from where to where? So from the shrimp to the small fish, okay? Then from the small fish to the shark. Okay, where else? From the tuna to the shark. All right. Now, is there any other energy flow that can happen? So this tuna can eat the small fish as well. And what else can happen? So the tuna can eat the shrimp. Okay. Now, if there is pollution in this environment, since everyone is interconnected, everyone is going to get a part of it. Everyone's going to get a part of that pollution because everyone is consuming each other. They're all connected in form of energy. So when we look at a possible food web, this is kind of what I created. And it's basically the same thing. It just shows energy flow. So we got that down. Now, I'm going to put these organisms in a food pyramid. Now, what type of organisms should be at the base? The producers. So these are your plants. I don't have any phytoplankton on there. I only have zooplankton. So we're going to have to remember that. Now, big thing is I'm on the arrow function, so I have to switch it to the select function, which is here, the top left. It's a little arrow. But now this will let me move organisms around. So which organism belongs at the bottom? So this zooplankton, we need to move it and place it on the bottom. Then what goes next? The little shrimp, krill, and then next, the small little fish, and then the tuna, the bigger fish, and then the shark. Now, there's a lot of energy that's at the bottom. And as I go up, I get less available energy. And that's what my food pyramid shows. And they're all interconnected through the trophic level. So they're all connected by energy. So when we talk about endangered species, remember, if I start manipulating the zooplankton or the small shrimp or the small fish, the shark's in trouble because it has a large size. It feeds at a high trophic level. There's not a lot of energy available. So those are the defining characteristics of endangered species. So that's where they become threatened. Now, not only is there not enough energy, they can become very sick from pollutants. Now let's see why. So let me show you my food pyramid. We do it exactly the same. This is kind of what we're going to start talking about of how pollutants can move through the trophic level. So when we look at it, zooplankton consumes 1 unit of pollution, whether it's DDT or mercury, just as an example. And this shrimp eats 3 zooplankton. So what we're going to do is we're going to show that this pollution is going to move from the primary consumer to a secondary consumer. So we're going to go here, we're going to select my pollutants, and we're going to go to the infinite cloner. And I'm going to move 1, 2, 3. Now, this shrimp has 3 units of pollution instead of 1. Why? Because it's eating an organism that has pollution. So now let's look at the small fish, the one above it. It's going to eat 3 shrimp. So I want to represent that by selecting all the 3, and I'm going to group them so that we can move it as one unit. And I'm going to do the exact same thing. I'm going to do the infinite cloner and go 1. Oh, I just need to make sure I deselect it here. 1. Oh, I've been having problems with that too. It won't let me just move it. They said I have to make sure I don't click on it or something. 2. And I'll click over here on the gray. Oh, there it was. 3. So now we have the zooplankton has 1 unit pollution. The shrimp has 3. How much does the fish have now? Now the same thing's going to happen is I'm going to group them. And I'm going to clone it. Now, how many small fish is the tuna going to eat? Yeah, 3. So this is 1, 2, 3. Look how much pollution is in tuna. And that's why they recommend women who are pregnant shouldn't consume high levels of tuna. Because tuna contains a lot of mercury in it. It can. And we'll get into where that mercury is coming from. It's coming from our fossil fuels. But this is why. Because it is building up through the trophic level. It's adding upon itself. It's not that the fish is consuming a large amount of mercury. It's that this tuna is eating things that have mercury in it. Now, let's go to the next level, the next trophic level. And let's go to the shark. The shark, we're going to say, is going to consume 3 large fish, or 3 tuna. So we're going to go 1, 2, 3. Look how much pollution is in your shark. And this is why they say it's very dangerous to eat things very high in the trophic level. It's very dangerous to eat whale, to eat shark, alligator, bear, lion, tiger, because they contain a lot of mercury, of DDT, because it's building up. And these DDT can cause problems in organisms like the eastern brown pelican. It can affect their eggs. The American bald eagle, it affects their eggs. So this is all part of movement of pollution. Since we're talking of movement of pollution through the trophic levels, from primary consumers, secondary consumers, to tertiary consumers, this is getting magnified. That's the idea behind biomagnification. It's the increase of pollution through the trophic levels. That is biomagnification. That it's building up pollution as we travel through the trophic levels. Now, let's look at, well, how's that different than bioaccumulation? Well, when we look at bioaccumulation, we'll kind of look at one little fish that's going to age. It's going to get older. And each day, it's going to consume 3 shrimp. So we're going to do the same thing. I'm going to select the little pollution, and I'm going to clone it. And this is going to be day 1. So this is 1. Let's move it. It moved it there. Okay. 1, 2, 3. So in day 1, it consumed 1 shrimp that contained 3 units of pollution each. So in day 1, that's 9. Now day 2, I'm going to do the same thing. And it's going to consume 1, 2, 3. So on day 2, it gets another 9. On day 3, the same thing will happen. 1, 2, 3. And then day 4, the same thing will happen. 1, 2, 3. Pollution is building up, but why is it building up? The amount it eats every time. This is bioaccumulation. It's building up of a toxin within an organism, within itself. So let's kind of see these together. Biomagnification is moving up through the trophic levels. Bioaccumulation is building up of toxin within the organism in its lifetime. So where you see this is if you go fishing in a lake that contains mercury, it often has a sign, only eat 1 fish per week, and that's it. And if you're a woman that's pregnant or small children, you shouldn't eat fish from this lake. Because if you eat 5 fish, this is what's happening, bioaccumulation. So this is the big difference between biomagnification and bioaccumulation. And I guess the big thing that I have to be careful with is when I'm doing this cloner, I have to click on the little dot that it represents, because if not, it just gives me that blue thing. But, all right. So is there any questions on that? All right, we got it? All right. Very good, very good.